Interesting that her PhD is on the teaching and learning of archaeology, teaching 3rd and 4th graders at the Houston Museum of Natural Sciences. And I'm excited to hear about our conversation today on engaging scientists in outreach with real people.
So if I'd known, I would have said Susan Renoe Science Ed, because my PhD is in science education. So I have a bachelor's and a master's in archaeology and an MA and a PhD in science ed in teaching and learning. The science educators in California were crazy enough to take an archaeologist into their hearts, so that was good. Question, how do I advance? Can I use this one? Will it work?
It should.
Yes, all right. So I am the director of the Broader Impacts Network here on our campus. I'm also the PI on an NSF-funded project called the National Alliance for Broader Impacts, and they brought you those lovely swanky pens. So thank you to them. So where are we headed? I love the green screen. It's kind of fun. It makes me feel a little bit fancier. This is going to be an interactive conversation. I'm sure you've all been in presentations where people talk to you forever, give you everything they know about a topic, and then say, you have any questions? And by the time you get done, you're like, I don't have any questions because my brain can't process all those things that they just told me. So this is going to be an interactive conversation. I brought you pen and paper. We're going to be using this paper that I gave you a little bit later. But there will be times when the screen will be blank. And when the screen is blank, you get to fill in the answers. So there'll be lots of interactive. So where are we headed? We're going to talk about engagement. What is it? What are the benefits of engaging the public in your work? Opportunities and barriers to engagement, which is where you guys get to start the conversation. Some examples of engagement. We're going to talk about the Broader Impacts Network. And then we're going to talk about building your BI identity. So they invited me to come and talk about broader impacts. I spent a lot of time talking about that. It's very much focused on NSF. Outreach and engagement is not unique to NSF. Having to explain the significance of your work and engaging the public in what you do is universal. Across funding agencies, more and more people are talking about it, they just give it a different name. So we're going to talk about engagement instead of just BI. Anyone know who this is? Most people don't know. His name is up there. Usually I just put his picture up there. Very few people know who he is. Doug Randall, who is this?
That's Lamar Smith, but don't ask me.
So this is Lamar Smith. He's the chairman of the House Committee on Science, Space, and Technology. Why is he important? That committee, number one, is the committee that is responsible for refunding and reauthorizing most of our federal funding agencies, especially NSF. And he's also been the one who's been leading the charge to really look at the NSF merit review criteria. And he wants to make sure that every grant application is relevant to the national interests. And who decides what is relevant? Lamar Smith. So he is very important to you in terms of being a researcher. A lot of what happens in Congress has a direct impact on your research lab. Most scientists don't understand that. But when we talk about broader impacts, a lot of people thought it would just kind of go away as a criterion for NSF. It's actually mandated by Congress. It's written into congressional law. So it's not going away, and NSF has taken it up. And if you were to look at the legislation that they put forth here, a lot of what you see in the law is directly correlated to what you see in the NSF guidelines. So he is very important to us. Anyone know who this is? There's a hint there, too. This is Dr. Franz Cordova. She is the new director of NSF. She's not so new anymore. She's been there about 18 months. But if you look at what she said, we need to stay relevant with those who entrust us with taxpayer funds. We need to reach out to Congress and other stakeholders and be proactive in explaining why we are vital to our nation's future. You see the word relevance there. It's highlighted in both of them. Broader impacts, as I said, is pretty much unique in its terminology to NSF. Everyone's talking about societal relevance, not just here in the United States, but overseas as well. They use that term a lot. I've been talking with our colleagues from overseas. You hear things like knowledge mobilization, knowledge utilization, societal relevance. In the Netherlands, they call it valorization. It's all the same thing. It's how we tell our message to the public. And across the world, they're trying to figure out what to do with shrinking budgets. How many of you feel like you have enough money for your research? All of us put our hands down and we're like sitting on them because research budgets are shrinking. So they have to figure out who they're going to fund. So what is engagement? Engagement is sort of the term du jour. I didn't know a whole lot about engagement really as a term until I started teaching a course called Public Engagement in Science, Public Understanding of Science, and I started getting into the public engagement with science and technology literature. Anyone know what the deficit model is in terms of thinking about engaging the public? Come on, science educators. The deficit model is sort of the idea that we as scientists and as researchers have all this knowledge and that the public isn't that bright. What we need to do is give them all this knowledge, and of course if we just explain it really well, they're going to get it, they're going to say we're really smart, they're going to take our word for it, and they're going to vote accordingly, right? How many of you think that's working? Not so much. It has worked in the past, but today people are asking, what are you spending my money on? You should be asking, what is the federal government spending your money on? When I go on trips for NSF, I'm spending your money and my money. Am I spending it wisely? Am I doing it well? So the idea behind engagement is that you're involving the faculty member in reciprocal partnerships with the community. So I have reciprocal highlighted and I have for mutual benefit. The idea is that we no longer just give the information out, but we're going to work with our communities to bring information in. I work with our university extension. Extension was created to take the knowledge from the university out to our communities. And what I'm supposed to be doing is help to integrate the researchers on our campus with our extension resources. And I ask, how do we know when that's worked, when we've really integrated those two things? And my thought is that we have this great research going on, we take the results of it out to the public, then we talk to the public and we engage them in conversation and we say, how is this benefiting you? How is this helping you? Or what could we actually be studying at the university that would actually help you? So instead of all the information going this way, the information starts going back this way. So university research is informed by what the community and the public is telling us, and then we're also informing them of what we're doing. So it's the idea that we bring people together into our research. So what are the benefits of engagement? And that's not a real person. It's kind of hard to see it in the green, but what are the benefits of engaging the public in your work? One is it's good for the community. If you look around, there are a lot of people who are interested in science and technology who are young children in the community, right? But they may not have access to it. We had a student who worked for me in the Express program who was from a small town south of Jefferson City. She was valedictorian, she was super smart, she came to MU, she's done very well, she's a Goldwater scholar, and no doubt she's going to be really changing the world for science one day. When she got here, her mom said something to her about, aren't you going to be a doctor, or, you know, what do you want to do in science? And she said, you know, Mom, we didn't learn about any other careers in science except for being a doctor. We never even heard that you could be a researcher. We never even met a scientist before, right? So there are a lot of people in the community who would be very much interested in alternative careers, who want to know more about coding. Hour of Code, right? We've all heard about this. Microsoft did a great thing, right? They plugged in Minecraft. How many of you have seen Minecraft? If you have any children, Minecraft is probably driving you nuts. So what they did was they hooked up with the Hour of Code, and now they've got kids coding using Minecraft. My 10, 9, and 7-year-old are busy writing code by using Minecraft. Now, do I always say you should be involved in video games? Not so much, but in this instance, it's pretty cool, right? So it's good for our community. If we put together outreach programs that are bringing our science out to the public, it's good for them. It's also good for our institution. How many of you know that our institution might have a small image problem right now? If we talk about the things that we are doing here, what is the benefit of having a degree, a higher education, an institution of higher education here? What is the benefit of having a Research One institution? My in-laws live on the family farm, and my father-in-law is kind of my ideal person. If I can explain to him what I'm doing and why it's important, then I've mastered it, right? He's my ideal public. Does he understand what's the benefit of having an R1 institution right here? What's the benefit to our new education? What's the benefit to our community? So it's good for our institution. It's also good for you as a researcher. So one of the things that, and the reason why I have a job, is that because NSF requires people to be their projects to be reviewed on the intellectual merit and the broader impacts, a lot of our scientists totally rock the intellectual merit. They get the science. They totally do. Some of them actually also get outreach and engagement, but not all of them. And so what my job in my office is to help researchers design and implement their education plans, their broader impacts plans. And the truth is, a lot of people thought that they were sort of an add-on, that nobody really kind of paid attention to that. They are really paying attention to it now, and excellent broader impacts are getting people funded. We're seeing that over and over and over again. So for you, the researcher, it increases your chances of getting good funding. The other things that we're seeing is that if you're involved in engagement that you feel excited about, things that you are very interested in, it can inform your research. And one of the things that I think is really interesting is that researchers who appear in popular magazines, newspapers, and journals also seem to have higher citations now. People are using it's raising their stature, and that used to not be the case. So one of the things I thought was really cool is that there was this bumper sticker that was going around that said a 10% pay line isn't funding, it's a lottery. How many of you know how many proposals NSF gets every year? Want to guess? 44,000. Do you know how many they fund? A little bit better than 10%. Across the directorates, they fund about 25%. That's, 1 in 4, right? Could you imagine what is it that's going to set you apart from all the other ones? And for me, it's the integration of your research and your outreach. It's when they look at it and they go, wow, this is stellar science, and they're taking it out to the public and they're disseminating it in awesome ways. And that's sort of what we're trying to do. How many of you have NIH funding or know what NIH is? Everyone wants the large R01s, right? One of the things that I saw that was very interesting is that only 3% of PIs for R01s are under the age of 36. So what is it that's going to make you stand out in addition to the great science that you're doing? And I think it's outreach. And then just so you know what this is, come back, there we go. Just so you know what this is a picture of a young woman who's participating in a program called Summers at Mizzou through 4-H, and she's learning nursing skills. And so that's really not a real person. So what are opportunities for engagement? And this is where I want you guys to be engaged. Give me some opportunities where you feel like you could be involved in engagement. Involving the public. It's not a trick question, I promise. Don't make me call on you, Heather. How do you engage the public in your work?
Carefully.
Why carefully?
Because if you say the wrong thing, they can misunderstand what you're trying to do and why you're trying to do it.
Mm-hmm. So how do you do it, besides carefully? What do you actually do?
Recently? Let's see. So recently, I'm on the board for the Biomedical Sciences program at the Columbia Area Career Center, which is a way to funnel high school students from all backgrounds in Columbia into science and engineering programs, particularly bioengineering. So I interact with students on that and develop curriculum and things like that. But there's the basic ones like going and giving a talk to the general public, like our Saturday morning science. That's the clear, obvious, easy. Look, there's a whole auditorium of people who just came to hear you. But that's, I think, the simplest way to do it.
So what are some other examples? Those are two really good ones. Bring high school students, and what else?
I hosted high school students in my lab for 2 summers, and she actually presented a poster in Hickman High School Science Showcase. So that's one way she can talk to her friends how, what is scientific research, especially in the lab.
That's right. So one of the benefits of it is that when you train somebody in what the actual scientific method is, they can go and train other people, right? What are some other opportunities?
I work on a course where we connect with farmers in the region to find out what problems they're facing, and we use those problems to engage undergraduate students in meaningful learning opportunities.
So now you're talking about two different things. One is undergraduate research, which is one of the most popular ways to engage the public. And then you also talked about actually talking to people outside the university about what their needs are. I love that. Other opportunities for engagement. Picky, all right.
One of the things I'm involved in is Caleb Science Club, and it's run by Dr. Ingram here on campus. And what he's trying to do is to involve the community, specifically students who are in high school, and get them involved in science and hands-on training. And that helps make them realize that there are other opportunities in science outside of being a doctor.
Or a dentist. Absolutely. Yes.
So I'm a chemist, and the ACS, the American Chemical Society, they have an ACS ambassadors program, and they're basically recruiting research chemists, professional chemists, to participate in engagement of the public. And one of the ways you can do it, they have pre-made chemistry sets to take to classrooms and schools. So I go to elementary schools, I go to middle schools, I go to high schools, and depending on the level, I show them stuff about luminescence and things like that. It's always a success. Nobody does not like science.
That's right. That's right.
So,
Two things there. One is that Houston Academic Professional Society. A lot of professional societies have programs like that. I think one of the misconceptions about doing outreach, and that we can talk about when we get to barriers, is that it's perceived as not being as prestigious, or that your scientific peers are not going to accept that. But there are a lot of professional societies, including AAAS, and what do they publish? You know, that small little journal that people don't care too much about. They very much care about public engagement. In fact, they have a center for outreach and public engagement. So that's one thing. The other thing, too, is that talking about doing outreach in schools. Teachers, what is the problem? One of the barriers for doing outreach in schools?
There's not a lot of time in the day. They have to cover so much stuff as required by state and federal law, and then you're asking them to take some of that aside and let you come in and talk to them about something that may not be covered by their curriculum.
That's exactly right. Everybody loves science. Nobody doesn't like it when experiments work or when you're doing things with science. But trying to figure out when is a good time in their schedule to do that, right? That's very important. Any other opportunities for engagement?
I recently worked on a field trip with Rockbridge High School. They came out to Tucker Prairie, and I was showing them insect morphology and taxonomy.
That's right. So bringing people in. So we took my kid's school went down to visit the Solar Village at the University of Missouri in Rolla, Missouri S&T. They loved it. And these were little people. I think another thing that could be a barrier too is that sometimes we think that kids are too young. Yes, it might require a little extra work, but nobody doesn't like science. Everybody wants to see what you're doing. They care about those things. One of their favorite parts was they went to see where all the solar energy was charged in the batteries, right? And on the ground, there's this line that's like the dead line. And if you go too close, the arc light can come out. And my son was like, "It's Force lightning. It's Star Wars, right?" So they're all over that. So nobody doesn't love science. So what are some of the barriers, right? What are some barriers to engagement? What stops people from doing it? Time.
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 Yeah.
What else?
Fear.
Fear. Money. All this costs money, right? I mean, researchers would love for me to help them on their projects for free, but I have to feed my family too, right? So all of our time costs money, right? So time, fear, money. Let's break that time down a little bit more. What do you have to do in your day, Heather, huh?
Herd cats. I have a large number of cats, and they all need herding in very different ways.
You have to teach, right? You have to do research. You're supposed to do service. This is what comes back to the idea of engaged scholarship, right? Is that it's supposed to bring those three things together. If you can figure out how to do something in terms of outreach that you really like, for instance, a lot of our scientists work in their kids' school. They're going to be at their school anyway. They might as well do outreach at the school, right? So you have to do all of those things. In addition to that, we're asking you to do outreach, and some people call that the fourth mission. I've heard that a lot. Outreach is the fourth mission. Some people don't like that. Some people think that's great. A lot of people would like to see that rolled into it so that the fourth mission becomes those three missions, and they call that engaged scholarship. So you have to spend time. You have to figure out when you're going to do that. So my answer to that is to, again, do something you like. When I come and talk to people about broader impacts, a lot of times I feel like I need a t-shirt that says I'm not the broader impacts police. I'm not here to tell you what to do. I'm not here to make sure you're not doing it right. I want to help you find something that you really like and you enjoy doing. How many of you like social media? I do not like social media. Not because I don't like it, because I'm not good at it. I barely can embed something in my tweet. I mean, I'm terrible. When I tweet, people know. They're like, are you tweeting, Susan? It's like a kindergartner is writing, right? You know, like, they know when it's me and not my grad students. So I hire people to do that kind of stuff. How many of you like talking in front of the public? Like making public talks? So, a few of you like that, right? How many of you like videos and podcasting and videos and YouTube and that kind of stuff? Me neither. How many of you like junior high school kids? How many of you like high school kids? How many like kindergartners?
Yes.
Oh, yeah.
Right? So the thing is that you notice that people here like different things, right? Don't ever do something you don't like. People ask me all the time, Susan, what is like the one thing you need to do? What's the golden ticket for BI? And I tell them there is no golden ticket. There's no one thing. Most people think it's working with high school teachers. If you don't like teachers, don't do it. If you don't like social media, don't do it. Find the thing that you like, right? Chris Pierce, who works in this building, Chris Pierce rocks at Twitter and social media. I would encourage him to use that as his BI. Figure out to find things that you already like in your personal life and do that. So, time, huge thing. Fear, what are you afraid of?
Being wrong.
Doing it the wrong way. Yeah. When I first started this job, I did a needs assessment with researchers, and overwhelmingly they all said, I will never do anything with teachers again until I talk to a teacher. They're afraid they'll do it wrong, or they know they'll do it wrong because they don't understand it. What else are we afraid of? Our colleagues won't like it. It won't be valued, right? Tenure track. You got to get tenure and promotion. I don't know about you, but I hear a lot of researchers say, I'm told by my mentor in the department not to do outreach until I have tenure. I'm not supposed to do that now. It's not valued. Any other things that are barriers to engagement?
I think there's also a certain nerdiness about scientists that sort of limits it, I think, and they know it.
Well, and let's be honest. We all know some people who should not be out talking to the public. And I don't mean that in a mean way. We know that there are certain people that's not their thing. In fact, I work with a researcher, and he is the sweetest man. And he just comes off kind of aloof and cold, and he knows it. And he says, I can't call him on the phone. I have to go down there. Because he knows that on the phone, he doesn't come off as the most warm, but in person, he knows how to deal with that. So the thing is that some people are afraid. And they know they come off, and they're not supposed to, and that's okay. One of the things that we're working on is a set of training videos for our office, and thank God I don't have to be in front of the camera. I love to talk to people, that's not a problem, but I don't want to be on anybody's camera. Other people can do that part, but you can contribute the information, right? So, it's so bad it's green. So Helen Quinn is a retired particle physicist from SLAC at Stanford University. And she says, engaging the public can be as easy as sharing an opinion with a local reporter, giving a lecture at a science cafe, or visiting a local science class. So here are some examples, because examples are fun. Unfortunately, these are green, but that's okay. So this right here is the graphic for our science cafe. And you can see they have things on astrophysics, there's things on plants, fracking, Neanderthal biology, autism, drones, all kinds of things. The public really actually wants to hear about a lot of these things. And the Science Cafe is a great way to do it. You go and have dinner, they have a beer, down at Broadway Brewery. It's very fun. The University Club here also has dinner with the scientists. You can go and talk about anything you want to. So pick something that you like. It doesn't have to be the whole totality of your research. Someone explained it to me this way, and I really liked it. When you go to get your car fixed, do you want the mechanic to tell you everything about how your car runs? I just want you to tell me what's wrong and how to fix it. They don't need to know the totality of everything that you're working on, but they do care about some of it. This right here is a picture of a young man who's at our observatory here on campus. Angela Speck is one of my favorite people, and she does outreach awesomely. It reflects her research. It reflects the fact that she runs our observatory here on campus, and this is from our museum crawl. And there are hundreds of people who come. We also have the Haunted Observatory. She trains her graduate students and she trains her postdocs and everybody who's working with her to do outreach through these programs. This is one of the lab tours, here, and then we can see the kids are in the lab and they're looking at the microscopes. There's another picture of them actually doing some things. This is Tommy White. She runs the electron microscopy core here on campus. These are students from Lee Elementary School, which is an art expressive school here, right, like steps off campus. They come in and they look at the microscope images and they turn them into art. How cool is that? Getting kids to think about science in different ways. And then this, well, I think it's a dog, to be honest, but I'm not quite sure, but it's a bunch of bones, which is really fun, from dinosaurs and cavemen. Casey Holliday in our anatomy department does this awesome thing at Rockbridge High School called Dinosaurs and Cavemen. As an archaeologist, I like the caveman part, because you get to break stone tools and do fun stuff. But they plug it into Rockbridge High School, get hundreds of kids to come. They use the planetarium. They talk about all kinds of things. It's very fun, and it's all related to the work that they're doing. This is some of the programs we have through University Extension. This is Pearls of Production, which is a very interesting program. This right here is a machine that helps people during rescues, like their grain silos. Grain falls on people and they suffocate, right? This is a thing that helps with that. They also have the Youth Development Academy through 4-H. They have this program through summers at Mizzou, which everybody loves. You know why? 4-H runs it. It's a summer camp. They run 2 one-week sessions in the summer for junior high school and high school kids. Students pay, so I keep moving. She's like,
no, you're good. You're fine.
Students pay to come. They spend a week here. Our researchers love it because all they have to do is come up with the science for the kids to do. 4-H takes care of the dorm. 4-H takes care of the meals. 4-H hires all the people to chase them around and supervise them when they're in there. It doesn't cost the researcher anything except they have to come up with the time and figure out what the camp is going to be, materials-wise, but it's free, and it's awesome. They had one last year on hacking. They do them on building a business. This coming summer, Mike Harmata in chemistry is going to be doing one called Dyeable Chemistry, which is way cool. Look at all the things you can do with dyes. So there are lots of programs that are already existing on our campus for you to totally plug into. So we're talking about engagement, and I'm telling you all these great things you can do, and you're like, who will help me do this? On campus, there are tons of people who do this and are willing to help you. And that segues into the Broader Impacts Network. That's us. We're here to help you. So how can we help you do this? I know you're jazzed. I know you're excited. You're thinking about how you can do this. How can you do this? So one of the things that we do is we will do one-on-one consultations. So we'll meet with a researcher, and they'll say, I don't know what to do, Susan, help me. And we'll say, what do you want to do? And we'll talk through it, and we'll come up with a plan. We also build partnerships with the BI collaborators. There are tons of people in our state and around the world who want to work with you doing outreach. We got a scientist, a geologist in Rolla hooked up with the 4-H folks in Arizona where he does research because of our connection through our network. So we want to help you find great ways to do that. We can answer your questions. If you're thinking, Susan, how's this going to work? We can answer those questions. And we can help you tell your research story to stakeholders. This right here is one of my favorite Broader Impacts programs. I just love it. I think it's way cool. Carol Ward in our med school does research on human origins in Africa. And for her Broader Impacts plan, she said she was going to do outreach to the local school in Africa to talk about what they're learning. When she got there, there was no local school. It had closed about 20 years before. And so she formed a nonprofit organization to build schools in that area to do outreach. How cool is that? You're not only getting to do something cool with your research and education-wise, but you're making a difference in the communities where you're working, which then does what? Shows the value of the research and trains the public to know more about what you're doing and why it's valuable. So today, you get to build your Broader Impacts identity. So you have the handout right there in front of you. We talked about NSF not being the only people who do outreach and engagement, but we're going to use NSF's criteria because I just like them and they're easy, and just about anything you want to do fits under here. So NSF gives about 9 things that are suggested areas for broader impacts. You don't have to be stuck with them, but most things fit under there. And if you don't believe me, look at this one. Improved well-being of individuals in society. Come on. Anything you want can pretty much fit into that, right? So the first thing I want you to do is to look at that, and I want you to pick 2 goals that you think you could accomplish with your research. With your research in general. Did you get one? You did. So with your research in general. So look and see, thinking about the research that you do, what could you do? And if there's more than one, feel free to check more than one. Oh, we can't see, it's dark. And I apologize for that. So then the second thing under there, and thankfully it says it on your sheet, I think, is it says list how your research can accomplish these goals. So what you're doing is you're thinking about what you could do and how it can work. The nice thing about this particular sheet is it fits nicely with our other guide sheet for writing a broader impact section. So if you were putting in a proposal for NSF, you could actually use this particular sheet to help write that. And we have a guide sheet that goes along with it that helps that. And the last thing we want you to do is just to write some public engagement activities that you think you can do related to the things you're talking about. So this is personalized to you and your research. So the BI identity, we keep writing while we talk. The BI identity workshop was created by my colleague Julie Rizzi at Oregon State. And the idea was to get researchers to stop thinking about broader impacts or outreach and engagement as sort of a set-aside add-on thing. Well, one of the problems I have with NSF in terms of broader impacts is that it trains researchers to think about research projects on a project-by-project basis. So you come up with a great BI plan for this grant, it lasts for 3 years, the money goes away, so you do something else. Well, just tell me what I need to do to get this research project funded. And then I do it, and the money goes away, and I go on to something else. What we really want researchers to start thinking about is not broader impacts in that kind of limited thinking, but across the course of your career. When you start off as a postdoc and start your career, you think about, what do I want people to say about me at the end of my career, right? What do I want to have accomplished as a researcher when I get to the end of my career? We want you to think the same way about your broader impacts and your outreach engagement. So if you start thinking about, what is my identity? What is it that I really like? What do I want to accomplish? Think about if you started an outreach program your first year as a new faculty member, and you continued that over the course of 10 years, 15 years, 20 years, what kind of data could you generate? What kind of difference could you make? What kind of impact on your community where you are could you make? Because I think, personally, the idea of doing broader impacts on a project-by-project basis, is that getting us what we want? If you really want to see more diverse people, more diverse backgrounds involved in science, is having one undergraduate from a minority-serving institution in your lab for one summer going to really change that whole culture? Maybe. It could do some good things. But what if you had a program for 15 years where you brought underrepresented groups into your lab, and it wasn't just your lab, but it was your colleague's lab, and then it was your other colleague's lab, and all of a sudden you're actually doing something over a long period of time, and on top of that you're evaluating the effectiveness of that, and you're writing about this program, and you're publishing about that program. All of a sudden you're doing this great research over here, but you're also having an impact in your community, and it's also helping you grow your prestige as a scientist, right? So this is this radical idea we have. We're trying it out. We think it's pretty cool. I hope that you will too. This idea of figuring out what kind of difference you want to make and looking at it longitudinally. The other thing is, my daughter loves Lego robotics. She's been to Lego robotics camp here at Mizzou. Her secret ambition is to build a robot that will clean her room. And she has no qualms about telling me, right? I don't care what she makes. If she does that, she'll be rich, because every mom and every kid will want one, right? She went to Renoe robotics camp last year. No one's following up with her. No one knows if going to Lego Robotics Camp this one time as an 8-year-old will impact her choice for career when she's a 18 and 19-year-old going to college. We don't know if her going to Lego Robotics Camp is going to impact her decision to come here to MU or not. So that's not the program's fault, but there's an inherent problem in that. We don't track them. We do these one-off things, we send them on their way that are inherently good, but we don't know if it made a difference or not. So when you think about broader impacts identity, where you think about where you are right now and where you want to go, you're thinking about building something that could actually have lasting implications, right? So I'm a little crazy, but I think it's kind of cool. So let's talk about this for a minute, because we have a little bit of time. Someone want to talk us through their sheet? I see lots of stuff there. You know you want to talk. You're smiling at me all the time. You're on the hook. Tell us about it. What did you write down?
Okay. Mine is improve STEM education and educator development at any level.
And what would you do?
Okay, by having some kind of PD programs, professional development programs, or by making it its importance significant for the stakeholders of STEM education. And, yeah.
So professional development for teachers. How many of you know that it's important for teachers to not only get professional development in pedagogy, but also in discipline-specific areas? If you want a teacher to be a better chemistry teacher, you want them to know more about chemistry, right? Makes sense, right? I know that I want a teacher to teach archaeology who knows what's happening in archaeology. So professional development is really important. Who else? You know you want to talk. You know you do. You have lots of stuff written down there.
I do.
Yes. What did you pick?
You can see that far away, but
I'm a mom. I see everything. I see stuff behind me right now.
I picked increased public scientific literacy and public engagement with science and technology. Was it the same thing that you picked? I can't
No, he picked improved educator development at any level. And that's important. NSF leaves that open from pre-K all the way through the Osher Institute for Lifelong Learning, right? So you can be working with anybody at any level. So what would you do?
Right. So, I mean, you could always talk to high school students and things about the research that you do. I don't know if it would be good to do like an after-school program or a program in between, maybe in between high school and college students. I mean, my research is fairly specific to a certain thing, so it would probably have to be upper-level high school or someone that I talk to, but you can always do that, or give public seminars like you were speaking about, science cafe, things like that. So get it out there, get the research out there.
You know you want to talk.
I like talking to kids. Like, I have a question about the barriers. Like, for me, working with plants, I want to show them how future farming can be so cool and so high-tech. The thing is, I'm not a kids teacher, and I don't know the pedagogy of kids. So one question is how do I get those advice to get the things that I want to say to the level of, I don't know, kindergarten or 8th graders or high school. You really need to adjust a lot. It's not like talking to students.
I think that's really one of the cool things about MU is that we have researchers who have dual appointments in the College of Education and in disciplines too, who can help you do that. We also have the ReSTEM Institute. There are a lot of people on campus who are experts in education, right? You don't have to do this by yourself. And I think that that's one of the barriers that I think, that's what my office tries to do. We serve as a matchmaker. We had a researcher in biology who said, you know, we used to have teachers who came in our lab all the time. I'd like to do that again, but the guy who did it is gone, and I don't know how to find teachers. So here's somebody who wants to do something great, but doesn't know how to find the teachers. And I say, well, I got lots of people who can help you find teachers. So I think one of the things that helps, and MU is fairly unique in the fact that we have a broader impacts network. There are probably less than 5 across the country, universities that have a full-time office, and most of them aren't full-time. There's probably only 2. 2 full-time offices whose job it is to help you find those connections. So absolutely. Other questions or thoughts? Yes.
Can I make a comment?
Sure.
Just trying to explain why we're here to do those kind of things is like we never done this before. See, it's like writing a proposal. You don't have preliminary data. You don't know if it's going to work. You just So it's easy to say we want to talk to high schoolers. We want to do this and that, but where to start? So I was fortunate when I was a PhD student and postdoc. My advisor he taking high school students in the lab for summer research, so we know how to talk to them, how to train them, how to tell them to run experiments and summarize the data and present finally. So I think that's a good model for me to follow. But meanwhile, I don't know other ways to get involved into other activities. So I think would be a good way if, for example, the current programs like in broader impact programs, they send out some notice saying, well, we're doing this, we're looking for, or we're welcome if you have these expertise, welcome to join our group, and this is what we are doing. And then it will be easier for us to identify ourselves with this specialty. We can probably fit into this kind of team, and we can learn from watching how others do those kind of work, and then it will be easier for us to pick up and develop our own ideas. So I think the starting is really difficult, but I think we have to resources. I just feel like at this moment I still have gap between myself and that already well-established program.
And that's one of the things we want to do. First of all, we want you to know that we're here to help you do that. But the other thing we also do sometimes is we also do a broader impacts resource fair where we bring everybody in one room, and it's like speed dating, and you can go and talk to people. The other thing that's happening that we're very excited about is in the next 2 weeks, we're rolling out an interactive broader impacts resource tool on our website. So let's say you wanted to find teachers. You can go onto this tool and you can search by region of the state. This is statewide right now. But if you wanted to work with inner city teachers in St. Louis, a lot of people are interested in working in Ferguson. There's a lot going on there. There's lots of need. So you wanted to find somebody. You can go through this search tool. You can put in the audience. You can put in the activity type that you're interested in, and it'll pull up not just, hey, there's a program, but the contact information and everything else. Now that doesn't take the place of knowing somebody and kind of making it a little bit easier, but we're trying to make more tools available so research, it's not so hard. It's closing the gap between the researcher and the resources. But you're absolutely right. Yes?
Can I ask a specific question?
Sure.
So you know me, one of my passions with broader impacts is recruitment and retention of underrepresented minorities in engineering. And I have been noticing a trend when I've been on NSF panels for the last 2 years that that's not really a thing that they look for when they're doing broader impacts. So it's been very interesting to sit on panels and have people evaluate people who are doing broader impacts activities in that areas as less integrated with their research than if I so an example of a broader impact activity I could do is I do biophotonics. I could make some sort of little biophotonics kit for K through 5th graders, take it out to the classroom, everyone would go, oh, that's such a great idea. But when people talk about I'm going to do better recruitment and retention of Hispanic students and get the pipeline in through that, the comments that I've seen for several years now have been that is not in any way integrated with your research. So this is frustrating to me because this is these are the things that I'm passionate about, and I've been getting knocked down this too in my proposals, and I see it, and so we had debates about this in our panels, like how is that not integrated with your research? You're bringing them in to do research. Well, that's just the lazy way to do it. So,
well, it's been very interesting. From my perspective, diversifying our scientific, the STEM field has been very important. And I see the opposite of it. I see almost that NSF puts, it's almost a separate category, that it's something that you're expected to do along with doing the BI things. Now, if you ask them if they would say no, but I've seen it in lots of solicitations that are coming out. How are you broadening participation in addition to what you're doing? The thing about NSF in general, in specificness, is that every directorate is different. Every directorate puts a different emphasis on different things. There are some directorates that really care about broader impacts a whole lot, And there are others that are sort of coming along a little bit. You know, they're getting it, but they're not getting it as well. What's interesting is that engineering in particular has been held up as an NSF directorate that really cares about broader impacts, and your director of that directorate has spoken very highly about it. So my guess is it's going to trickle down some. My answer for working with minority students, or in any broader impacts activity, it's easy to say, I'm going to get a high schooler. It's easy to say I'm going to do this, but if you don't have the partners to make it happen, it's not going to happen. You can write anything you want into a proposal, but if you don't have the people to help you make sure it happens, it's not going to happen. And I don't know how to fix your directorate. You just have to play the game, unfortunately.
So maybe one question. It relates to what you said. So I'm new at writing the grant and trying to figure out broader impact. How related it should be to my, because I went and had a draft and it was like you said, things I'm passionate, things I want to do, but they're not necessarily related to a specific research proposal. They're like, there's people, women in science, I want to do a lot of stuff, but they're not specific to this specific research. Do I have to have that?
So I'm going to tell you the party line, and then I'm going to tell you the reality. So at NSF, there are 3 things you can do. It can be directly related to it. Directly related. It doesn't have to be directly related. It can be somewhat related. Or it can be what I call tangentially related. Now that's the party line. If you look at the NSF guidelines, it says it doesn't have to be related. The truth is, most of the projects that get funded, it's easy for the panelists to see the overlap. So, no, it doesn't have to be, but yes, if you want to get funded, most of the time it has to be. It has to be there.
And that's what I've been seeing with the underrepresented minorities is everybody comes back and says it's not, like, it doesn't have anything to do with the specific research proposal that you're writing, therefore it's not integrated with your research, and if it's not integrated with your research, it doesn't count. And so
it's wrong.
And it's wrong,
It's
but
just
that's
wrong.
but it's like the last 10 panels I've been on, we've docked people on that, and I argue against it, and they're like, well, but this other proposal has this kit that they made, and they took it out to the school, and so that's directly integrated with their research, and this one isn't. And so that's
one of the problems you
frustration
have
I
too, is
have.
each panel is different, right?
Right.
So how unfair is that? There's a moving target. So you get a panel, and they say you're really great, but you just missed the cutoff for funding, right? So what do? You take your proposal and you resubmit it, right? Then you get another panel, and they're like, this is the worst thing I've ever seen. And that's confusing and upsetting. The other thing I've seen, and this comes out of the Geosciences Directorate, is that there seems to be broader impacts kind of goes in a box. And people, especially from our university, are really looking at innovative and unique, creative things that could really make a difference. And if they don't fit in the box, their panel is like, I don't know what to do with this. This is too innovative. This is something we've never seen before. We don't know what to do with that. And we've seen people get docked because of that. So the truth of it is, I'm going to keep telling you to do things that you want to do and you're passionate about. And I'm going to help you craft it in such a way that it's more palatable for your review panel. But I'm also going to tell you, you can't be too far out here. Until review panels are better educated about what counts, you're going to get dinged for it.
I think the guidelines are such that you can do pretty much anything, and it doesn't have to be directly related to the research that you propose at that moment. The problem comes in with demonstrating competency in what you propose as your broader impact.
Yes.
If you say something, you will do something that's not what you actually sort of have any reputation for, well, then they're stout. So the question is, do you propose something where you have a case to be made that you are competent doing that? And that's the hard part, But if you can make that, then I think you should go ahead with that.
The other thing, too, is that, so Mike Carmada from chemistry, who's doing viable chemistry next summer with Summers at Mizzou, he's the funniest guy, and he says, I don't know anything about teachers. I don't know anything about, creating programs for junior high school people. So what we did was, I have a colleague who's been teaching at a rural high school for 12 years in science, who also has a degree in chemical engineering. And so she's agreed to come and be the science the education coordinator for it. So she's going to take care of that part for him. So he partnered with her, he's paying her, and together they're developing the materials for the teachers, and they're going to work that. And in the proposal, we wrote that down. We hired her because she understands the Missouri State Teaching Standards. She understands Next Generation Science Standards. Because that's something that I think is really important, especially when working with teachers, is that we have this idea we're going to create this kit, and we're going to take it out. Do you even know where that kit fits in the curriculum? Columbia Public Schools, if you go to their website, you can look up what they teach in science for every year. Some of our scientists did that, and they're like, oh, I need to target 7th graders. I don't need to target 5th graders because they're not doing what I do. So do your homework, do your work on that. That helps. But showing competency is really important.
And one other thing is, I think we should not forget that we're basically not just researchers, we are professors. That means we also have a teaching component. And if you propose anything for broader impact that's related to your teaching experience, that is also counted by NSF, right?
Well, you have to be
So
careful
the
with,
education
but you have to be careful with that.
Yeah.
That seems to be one of the big sort of discussions right now, is what is your job, right? Training undergraduates, training graduate students, teaching. People look at that and they go, that's your job, that's not a broader impact.
Yes.
So what do you do to then raise the level of that to go beyond what you should be doing and what's amazing? So if you're going to do something with undergraduate education, then I would encourage you to do something more than say, I'm going to take my research and I'm going to use that to inform my teaching, which a lot of people do. I'm going to have an undergrad, I'm going to train a postdoc and a grad student, I'm going to have a publication, I'm going to make a presentation at a conference, and I'm going to inform my teaching.
That's not broader impact.
That's your job. But you can do undergraduate education, but you have to do something more. Flipped classroom, doing some classroom redesign, using technology, something that's more innovative in their eyes. So be careful with that one.
I would also, sorry, I also want to suggest, Heather, that if you're doing recruitment retention in undergraduates, that's an institutional capacity building change that you're making, which to me is a higher level than like a little project to go influence a few people
I agree.
in time, right?
I agree.
So if it's pitched that way, maybe that would help them see the broader impact.
It usually is.
Okay.
But so many of the panels I'm on, like they have specifically, like in their call, it says the broader impact activities have to be integrated, and integrated is the key word with the research proposed.
Okay.
And so it's like talking about building a lifetime program. Like I start this program and I do it over 20 years, and I have projects that come and go, and those projects may or may not be related in any tangential way, but these are students coming in. So that's a discussion that the NSF needs to figure out, or the NIH needs to figure out. But I agree.
And then maybe also just like if you feel like it's really something that's unfair that's happening, because that sounds to me like it could also be people who are maybe not so interested in supporting.
Well, again, I'm an engineering director.
That happens.
So two things that you
I
should
think
know.
you just hit it exactly on the nail.
Yeah.
This is it.
Yeah.
And if that's happening, I would complain to the person above. I don't know how to complain with NSF, but I would go to the person above and
that's
say,
a good question.
this
I don't
isn't
know how to
right.
complain because
This is
there are
happening.
people that I submit proposals to. So if I complain, then they're
Well,
not
so-
like me.
This is where we talk about this. So the National Alliance for Broader Impact is a network, an international network of people who do what I do. Two things we're doing that are of interest to this conversation. One is we just published a guide sheet for evaluating broader impacts that will be released nationwide and across NSF. That ties into the guidelines, and it basically says this is how you should be evaluating this, whether it's good or not. It goes through all those. So that's coming out, and it'll be out hopefully in the next month. The other thing is we spend a lot of time talking to NSF. I wouldn't say complaining, but dialoguing with them about what it's like boots on the ground, right? Lamar Smith and Congress, they make these big blanket legislative things up here. The NSB takes it, the NSF takes it, then it comes down to your directorate. This is what it's supposed to do, but how do you actually implement it? What is the impact on researchers here on the ground? And so part of my job is to talk to NSF and say, this is what researchers are saying. And one of the things I've been saying is that this seeming inequity across panels is problematic, especially if you say you want people to be unique and innovative and yet you ding them for being unique and innovative. How is that going to get you what you want? So part of it is our job as the mediator to do that. The other thing, too, is to continue working continue dialoguing with your program officer, and then training. NSF likes to say NSF is us, right? Most of the people there are rotators from campuses. People who sit on review panels are who? NSF funded faculty. So the more we train and our colleagues and our graduate students and our postdocs about how to do it and do it well, the more turnover there is, the better you're going to see.
Yeah, and that's helpful. I mean, the last panel I was on last week was 30 proposals were reviewed in 8 hours, and you get 15 seconds to talk about broader impacts, and you know, we all get the same standard. This is what a broader impact is at the beginning for training, the same standard 10-minute with 5 slides on it, and it doesn't explain anything, and then you get 15 seconds to talk for each proposal about what the broader impact is, and it's almost a split decision. Like, people are like, I liked it, I didn't like it, I liked it, I didn't like it. So.
Well, and one of the things that we do, so we have a guide sheet that goes along with this here to help you write your broader impacts. We know that people are tired and grumpy when they're reviewing proposals. They have to read so many, they don't have to hunt for it. We are very specific about the way we train our researchers to write their sections. Here's the goal, this is what I want to do. This is how I'm going to do it, this is how I'm going to know I did it. So here's the goal I'm meeting, which is straight out of the NSF thing. So here, this is what you said NSF, we're giving it back to you. Here's the things that go with that goal, and here's how I'm going to evaluate it.
Is that on your website? Because that's new since last time.
It's there. We have a guide sheet.
The guide sheet. Okay,
Mhm.
I'll look that up.
And anybody can use it. If you don't see it, we'll send it to you.
One comment about these broader impact statements. If you read the proposals that NSF gives, they have usually 150 references for all the research that is being described, yes? And then there are no references for the broader impacts. And so if I see something like this, that's not good, you know,
That's right.
because that simply means that the person is not academically interested in broader impact, has never read anything about it, does not know what to cite, does not know what is academically interesting or politically interesting or sociologically important. And if they don't have that, well, then they haven't read enough. Too bad. So, I mean, my recommendation would be, you know, if you write something in broader impacts, do it like a scientist. You
That's
know,
right.
read stuff and cite that stuff, and then show that this is important. People have said so, and these people are in different fields. So, you have to become a little uncomfortable and read education journals, for heaven's
That's right.
sake. Or you might have to read sociology journals or something, you know. And if you're a chemist, you know, well, that's a chunk, you know.
Ron, we're going to put you on our committee. We're going to put you on. You nailed it. But I always tell people is to write your broader impact statement the same way you write your research statement. Do all the same work, put your goals and objectives up front, here's how you're going to do it, here's how you're evaluating it, and definitely put in the references.
Okay, thanks for that.
Thank you for your time. I really
For your
appreciate it.
time participating. Actually,